Hello. Hi, good morning everyone. So I think that most of the people have joined, so I think that we can start the session for today.
Yes, sir, we can start.
All right. Thank you, sir. So the session for the planned session for today is specifically for the administration part. That is, how can you use the server? Like we talked about Dockers, right? So this is a bit forward than Dockers, that how would you create users, how would you create your instances and things like that. So the first part of the session is a little bit of theory where I will discuss with you the major components of your server, and after that we'll be seeing how to, you know, uh, do that in code actually
Okay.
using the hands-on session. All right. Okay. So, as people over here might be knowing that you guys have one of the best servers in the whole world right now, that is the A100, and maybe I would say that one of the firsts in India also, and that's the one of the best part of A100 is that it has multi GPU instance creations. So up until now, this was not the case inside the earlier servers and architecture, that was V100 and P100s and other DJX systems. But with the help of this very simple and very easy to do MIG creation, so we call it MIG, multi GPU instance, and multi-instance GPU creation, we are able to remove all the bottlenecks that we have for the other servers, that is earlier DGX versions. And I'll show you how it is important and why it is actually important. All right. So, firstly, what we had was the problem was in our case, or maybe in any AI workload case, was that you had a specific cluster for training, that you would have servers specifically designed for training. Then you would also have servers specifically designed for, after training deployment. And then there would be servers after deployment, analytics, and all. So, majorly your data center would be divided into these three parts. An AI data center or in an infrastructure would be divided into these three parts. So it was not very fully optimized. So over here you would not get good throughput, that okay, after training you want to port each and everything to the inference cluster, and then the inference cluster is not performing quite good at that, so you want to go back to the training cluster and then train it again, then come back to the inference cluster. So there was this inflexibility problem in the AI infrastructure. So what all was there? Constrained workload placement by system level characteristics, non-uniform performance across the data centers because we had a different servers for inferencing, different servers for training. Similarly, it was the user was unable to adapt to the dynamic workload demands. So it was possible that the system administrator is not able to keep up with the request coming in for the training cluster and the inference cluster. And there was also a little bit of constrained capacity planning. So all in all, what I want to say is with the help of the earlier AI workload, that the AI of maybe I would say 2020 infrastructure would be something like this, where you have different servers for different use cases, and people would use the same server for, like, people can use their training cluster for inferencing also, and their training cluster for analytics also. But this was actually the best optimized solution at the time. But now, with the help of A100, we break through all of those things. That is, we leverage the integrated expertise to solve problems faster with the help of the performance benefits that we are getting. Then, to support the AI lifecycle for analytics to training to inference, we have the best tools for all the jobs. So it doesn't matter that if you want to run a AI job or an inference job or even an analytics job, you can run any of those workloads on a single GPU, on a single server now. And obviously, it is giving breakthrough performance than any of the GPUs compared together up until now. It is getting it is receiving almost 2 to 3x performances as compared to the earlier GPUs. And this is one of the latest architectures in the field, that is the Ampere architecture. Earlier was the Volta architecture, and the Tesla GPUs were on the Volta architecture and they were the fastest. Now, with the help of the Ampere architecture, we are able to get even faster than Volta. And then you can get effortless scalability. Now, what do I mean by scalability? Like, okay, today you have, let's say, 50, 70 users that are working simultaneously on the system. Now, let's say tomorrow you want to increase that. So scalability is not a problem. Today you have 20 users using the server. Maybe tomorrow you want 40 users to use the GPU at the same time. So that is not a problem. Scalability is not an issue. So democratize access to resources for every innovator. So you have resources available for each and every job, each and every innovator. Now that is why DGX A100 is being called as the universal AI system. Now, AI, if the people over here who would have joined me from the day two of the training also, so you might be thinking that, okay, why am I not calling DGX a deep learning system? I'm calling the DGX as a AI system because it is possible to achieve all, because DGX A100 is now able to run all of the workloads, that incorporates the AI, that incorporates any of these things to inside just one machine. So you have one system for every workload, for every AI workload. It does not mean that you are running an analytics job. It does not mean that you are running a training or an inference job. All of them would be performance utilized. Then you have game changing performance for innovators. You have fastest time to solution with the world's first 5 petaflop AI system. So NVIDIA A100 is actually one of the it is actually the first AI system which is able to deliver these many petaflops of uh, game changing performance in just one machine. So earlier 5 petaflop system would be a 2 to 3 node server, or maybe a 4 or 5 node server. But right now with just a single node, you are able to get this game changing performance. And obviously, I talked about this unmatched data center scalability. That is, you get unmatched data center scalability, which means that you can scale your server, scale your GPU with respect to any of those workloads. Now, what makes this very important? So this makes it very important because with, yeah, is there a question? No? Okay. Yeah, so I was saying that your one system is for all the AI infrastructure. So earlier, what you had to do was you had to have a training cluster, you had to have an inference cluster, you also had to have an analytics cluster. But right now, with this just one server sitting inside your data center, all of these servers will now become obsolete because all of these servers were highly optimized for their jobs because they had different architecture, but now the A100 is highly optimized for all of these jobs together. So if you want to do analytics, training, inference, any job, any size, any node, any time. So that's a lot of promises actually. And you must be thinking that why am I praising that so much? Because but I am telling you the truth. This is actually a presentation that is created by NVIDIA only, not by me. All right. So we have flexible AI infrastructure that adapts to the pace of the enterprise. So it depends upon you that okay, today you want to have let's say 20 inference instances, and yeah, maybe next week you want to have just two inference instances. So things like that can happen for you. It is that scalable. Now, one universal building block for the AI data center, I talked about this, then it has uniform, consistent performance across the data center. So it does not mean that okay, if someone is running a inference job, it will take a lot of time, or it is not optimized for that analytics job. It is highly optimized for all of your AI workloads combined. That is, you can run any workload on any node anytime. So maybe you have more than one server. So what you can do is any of those workloads can use any of the nodes. So similarly, you get limitless capacity planning with predictability and great performance with scale. So maybe tomorrow you want to scale your server to maybe your server room to maybe from a one server to a two node or a three node or a four node server. So that is something that you can do, and then you can, you know, get limitless capability of scaling also. So one person can utilize the GPU in even a better way if the users increases and the utilization increases and things like that happen. Now, and what is making all of this possible? Okay, so I talked about everything can run on it, anything can run on it. So what is making all of this possible? So the thing that is making it possible is actually multi-instance GPU, which is Mig. And that is something that we'll be talking about in greater detail today. And this is actually the selling point, I would say, not the selling point, I would say, but the benchmark point or the novel approach that this architecture has. So if people over here are researchers, they must be knowing that okay, um, if your research paper can only get published if you have a novel approach or you have a better performance. But over here, this server not only have a better performance, but it also has a novel approach. That is, it is able to slice the GPUs. So over here, let's assume that you can get up to 7 GPU instances in a single A100. So and you have 8 A100s available inside your server. So a single A100 can be sliced into 7 GPU instances. So 7 into 8, that turns out to be 56 concurrent GPU instances at once. Okay. So what is the meaning of this slicing? So earlier slicing was also possible, but slicing was not possible up until the hardware level. So you could slice the memory, but you couldn't slice the CUDA cores. So if people over here would be knowing that how a GPU works, so GPU actually has in the hardware level, in the transistor level, they have cores that are called as CUDA cores that specifically do matrix multiplications and additions. So those cores were not being sliced earlier. The GPU memory was being sliced, but the cores were pooled. So what was happening is, if I draw it out for you, I think you'll be able to understand it better. So over here you have your cores. Okay, these are your cores, and on top of this you have your memory. Okay, so what you are doing earlier in the Volta architecture and Pascal architecture, what you were doing is you were slicing this memory. Okay, so you could slice up this memory, but what you were not able to do is, what would happen over here is, let's say you sliced your 32 GB into four parts. So 32 divided by 4 is 32 divided by 4 is okay, not a problem. So
8.
let's yeah,
Okay.
thank you. So this is 8 GB. Now the issue earlier was that if people might have used a single GPU, they would understand that okay, if you have sliced this memory at 8 GPU, so now what will happen is, if this person, okay, This person is utilizing his whole 8 GB of the job. Okay, so this is one GPU, all right. So this is one GPU, and people, what they have done is people, uh, this AI, this system administrator has spliced his GPU memory into four parts. So each and every user is able to get 8 GB, and each and every user is happy that, okay, I'm able to get 8 GB. But what the user is not actually understanding is they are only getting the memory, they are not getting the cores. The cores are pooled right now. So what if this user runs his job first? What will happen is, if this user starts running his job first and his job is really compute intensive, so he starts to use all of the 8 GBs. So what will happen is, because the cores are common, because the cores are pooled, so what will happen over here is he will start to use most of the cores. That is, maybe he will start to use 80% of the cores, and then maybe he's running the job first, so he has started using the 80% of the cores. Now these guys still have 8 GB of memory available to them, but now they only have 20% cores available, because the cores were not uh, differentiated, they were pooled, they were shared. So this was the case inside the Volta architecture and the Pascal architecture that was there, that even if you splice the GPU memory, even if you slice it, after slicing it also, this partition was not possible. But with the help of A100 architecture, with the help of the novel approach that A100 has of Mig instances, you not only get the GPU memory splice, you also get the GPU core splice over here. So this is what is important over here to understand, that earlier, if you had four users running one job on a single GPU, it would be possible that he might be using just 8 GBs, but he might also be using the whole 100% of the cores, because these cores, that underlying cores, are actually uh, pooled, shared, not restricted to one user. And it was not possible at that time in the hardware level to restrict the cores, because these was actually hardware. Memory is something that becomes as a software part of it, that you can do slice it, but slicing this hardware was not possible. But this was improved upon in the A100 architecture, and with the help of Mig instances, we are able to do this. So I hope that everyone understands uh, the basic advantage that you guys are getting with the help of A100. So right now, if you have like, let's say you have seven users working over here. Now these seven users will not only have their specified GPU memory, they will also have their specified cores. Now, if this guy starts to run his TensorFlow job, and this TensorFlow job is taking, let's say, whole of his GPU memory, so he will not get into anyone else's core. Okay, he will not get over here, he will not get over here. But in the case of Volta, in the case of Pascal, he was able to get inside this guy's cores also, and he was able to get inside this guy's cores also, because the cores were pooled. But right now the cores are not pooled, so he cannot do this. He cannot do this. He can only use his GPU cores, and he can only use his GPU cores. And this is the novel architecture that the MIG provides us, that you can splice the GPU into seven different parts. Depending, there are many profiles. I'll talk this more about when we are doing the hands-on session to define you about the profiles. But right now I just want to understand how the slicing is happening. So there must be users who are running their Jupyter notebook, there must be users who are running some TensorRT job, some TensorFlow job, some Amber job. So what would happen over here? They would be restricted inside their GPU memory. They would be restricted inside their CUDA cores. They would be only using the CUDA cores that was assigned to them. If you, when they were slicing the GPU memory, they also sliced the CUDA cores. So this is the novel architecture. This is the novel approach that I would say the Ampere architecture has. So this is what is called as flexibility to run any type of workload on a MIG instance. That is, you can run any instance over here. It doesn't matter. It doesn't matter you are running a inference job over here, you are running a training job over here, you are running a production job over here. So it is possible that a single GPU, this is only one GPU, okay? This is only one GPU. This is one GPU. Now you have eight such GPUs available inside your server. So it is possible that a single GPU is being used for training also, and it is being used for production also of the same application. It is used for another purposes also. So any of the thing that you can think of can be done inside the single GPU. And this is the beauty of MIG. All right. So lastly, I would like to say that GPU instances have you can create any number of GPU instances in a single A100. You have simultaneous workload execution with guaranteed quality of service. So this is actually the main thing to know about. So earlier, the splicing did not guarantee you quality of service, because if one person starts running his compute intensive job, so he would start using the whole of the GPU cores. So that was the issue. But right now, with the help of this slicing technique, up to the hardware level, up to the cores level, we are able to guarantee the quality of service. That is, no, this guy will also get the same compute as this guy. It is not possible that this guy will start using this cores and this guy will also start using this cores. Okay. So different size MIGs based on target workloads. So you have different size of MIGs also. Maybe if this guy wants to use more GPU memory, so he can get a bigger MIG instance. This guy wants to use it only for production. Maybe he wants it only for a single model, so he can use a less memory of the GPU. Or this guy wants to run a very big job, he can use a little more memory of the GPU. So things like that can happen. You have different processes available. You have different profiles available inside when we are creating a MIG instance, and I'll show you how to do that also. Okay. I hope that the MIG instance GPU optimization and actually what MIG is all about was understood by everyone, and what was the novel approach that was identified by NVIDIA, and which was actually identified by NVIDIA only in their earlier hardwares, and it was corrected by NVIDIA only in their next hardwares. So this is actually a very cool thing to understand, that they are learning from their own mistakes. Because in the Volta architecture, users actually got this issue that, okay, I have the whole of 8 GBs, but I am not able to use the GPU. I am getting resource out of memory. What is the problem over here? So that was the issue, that the cores were pooled. Okay. All right, I'll move forward. Okay, so the last thing is that more users can have better GPU utilization. So the types of MIG instances that are available over here are 5 GB, 10 GB, 20 GB, then again a 20 GB one, and I'll tell you that what is the difference between these two, and then a 40 GB. So your single A100 incorporates a 40 GB. So your total is the 40 GB of one GPU. Now what you can do is you can slice this 40 GB to 5 GBs architecture, 5 GBs memories up until 7. So, but then you would say that, okay, 7 multiplied by 5 is only 35 GB. Then what happens to the 5 GB? So that 5 GB actually is a overhead that goes inside each and every one only. So you cannot just splice it dot by dot. You can only slice it up to this much, because they have approached a novel. Maybe they can get it even better in greater updates. But right now, upgrades or updates. But right now it is like this: that if you have a 40 GB GPU, you can you can create 7 instances of 5 GB, 3 instances of 10 GB, 2 instances of 20 GB, and there is another 20 GB instance of 1 20 GB instance. So over here in this case, what happens is there's actually two different kinds of scenarios. That is, uh, over here you get different kinds of SMs. So SMs are actually streaming multiprocessors, and streaming multiprocessors are analogous to, let's say, your CPU cores, you can say. So over here in this one, you get less number of CPU cores, so you are able to design two 20 GBs. But over here you get more number of cores, so you are only able to design one. Okay. And then over here you can see that this is your um, whole of the server. Now you can do mix and match flexibility utilization, that the first GPU is being uh, the first GPU is being utilized by seven users altogether, and then this GPU is also being utilized by seven users altogether, and this GPU is being utilized by seven users all together, where over here they are doing the first GPU used for Jupyter notebooks, the second GPU, half of the second GPU, 60% is being used for training, and then 30% is used for testing and inferencing, and then again this over here. And similarly you can slice it, splice it according to it, according to how you define it, how do you want it. And over here in a single A100 server, you can get 56 concurrent users using the same compute. That is, if a user who has the small instance will also get the same performance and the same CUDA cores as the guy who is using the whole GPUs, but only he will get more memory, he will get more cores. But actually if you think about it in unitary perspective, they are all getting the same thing. All right, because one GB of anything is equal to that 1 GB. But earlier 1 GB was not equal to 1 GB. 1 GB was not equal to 1 GB because we were not splicing the cores also. But with the help of splicing of the cores also, 1 GB now is analogous to the number of cores also. So however you take out 1 GB, you are also taking out the number of cores out of it. So if this guy, let's assume, has 5 GBs of GPU memory, and he has, let's say, 1000 CUDA cores available. So this guy will also have for 5 GB 1000 CUDA cores available. So this is the concurrent nature of the Mig instances, that you can do better GPU utilization, and each user can do better GPU utilization, and therefore you can get more users to log in into your machine. Okay, so with the A100 over here, this is just a example to show you that, okay, this is what your A100 looks like. And inside this A100, you have 8 GPUs available over here. And you can specifically decide that, okay, 2 of these GPUs will be specifically used for data analytics. 4 of the GPUs will be used for training. And then again, 2 of the GPUs will be used for production. So this is the case inside many issues. So over here inside the server only, you have a mini server for training, a mini server for analytics, and a mini production server. So this was the case that I was saying earlier, that okay, you get best of all the worlds, best of the three worlds in inside one machine only, and with the same performance also. With because A100 is an upgraded performance, so you get upgraded performance also, and you get different types of workloads also inside the same thing. And all of this can be done with the help of multi GPU instance creation, that you can create instances accordingly. All right, and obviously the infrastructure that we have inside the DGX 800 is very flexible, it is elastic, it is not very, rigid. That okay, earlier what was the case, that okay, if you want to have an inference server, you need to first buy the inference server, and buying the inference server is obviously rigid. Today you have estimated that okay, you have to let's say two applications that are going into production. So you buy only a server with only one GPU, and let's say day after tomorrow, not day after tomorrow, maybe a month later, you get more applications on production. So the issue was, the scalability was a very issue, the problem. That is, traditional infrastructure was constrained on everything. But with the help of the DGX 800 agile infrastructure, with the help of the Mig instances, today you can have only one GPU for inferencing, and you can have two GPUs, one GPU, two GPUs for training, and rest of the GPUs for testing maybe, or analytics maybe. And let's say tomorrow you want to change this part, you can change this part directly, automatically, with the help of the Mig instances. You can create more instances for inferencing, create less instances for analytics, and create even more instances for training. Then again next week you can do it again. So DGX 800 uses MIGs to allocate GPU resources to the workloads. So over here with the traditional approach, you don't need to go outside and buy it. You can just add it directly inside your agile, inside your server. Okay, so this defines the elastic nature of the AI infrastructure. Now it is not rigid. Now it is not constrained. It is elastic in nature. All right. So with that, that was all about Mig and all about understanding the Mig instances in theory. So now I would like to open the floor for questions. If anyone was not able to understand anything, if anyone was not able to get to know anything, because this session is specifically built for the system administrators or the people who will be managing the servers to understand the power of the server and to help you get better leverage out of it.
One question, sir. Hello.
Yes.
Yes, sir. There are seven GPUs or eight GPUs? As
8
last eight
8
GPUs.
yeah,
Okay.
and each GPU has the capability to define 7 instances.
Okay. Okay.
So
Seven
that means
instances.
7, yeah, 8 GPUs, 7 instances per GPU. That makes 56 instances.
Fifty. Okay. Okay, sir.
I have one question, but not related with this, something different. That
Okay, ma'am.
what we have done, we have you have created one test folder,
Yeah,
and under the test folder we have created our own, and there we are doing our everything we are doing, right? So, but if I
yeah.
want to create my own folder and make it secure that nobody is able to access that one, so what I have to do then?
Okay. So in that case, ma'am, the system administrator will create a user under your name, and that user will be restricted with your password. And
Okay,
when all specific users are created, then you can have a secure, like right now, you were testing the server so that I wanted everyone to understand it. So
hmm.
over there I only created one user and everyone was able to access it. Now depending
Okay,
upon your team, whatever they decide, they can create different users depending upon the use cases, and then they can distribute it, I suppose.
okay, okay, thank you.
The use case that you are saying, that it is very much possible that you can get a restricted space for yourself also, not a problem.
Okay, thank you. Okay.
Okay, any more questions? And yeah, so one more thing that I wanted to specify was, to create a Mig instance, you need to be a super admin. That is, you need to be an admin user. The test user, the test that we created yesterday, right? The test that we were using right now is not an admin user. So when you are inside a non-admin user, you cannot create a Mig instance. You can only create an instance when you have super user rights. Okay, so looks like there are no more questions. So now I will show you how to create a Mig instance, and then I will log in into that Mig instance to also show you, you know, how you can run Jupyter Lab inside that Mig instance. Okay, so firstly, this part is very important to understand for the admin perspective. So the admin needs to create the GPU instances. All right. So whatever commands I'll be running over here right now, I'll be sharing a whole document of it so that you guys can keep that as a reference also. So not a problem. And creating a Mig instance is very simple. Okay. Firstly, over here, we will do a NVIDIA dash SMI. Okay. So we can see over here that we have all the A100s listed right now over here. Okay. And this disabled flag that you see over here, the meaning of this disabled flag is that the MIG mode is disabled. So right now, if this MIG mode is disabled, the person can use the whole 40 GBs of this. Okay, he don't want to, if he wants to use a MIG instance, so firstly the MIG instance needs to be created. The MIG service needs to be enabled. Okay, so for enabling the MIG instance, I will only show you how to do a MIG instance on a single GPU. And that thing can be utilized and can be scaled out for all the GPUs also. So NVIDIA, and everything is possible with the help of just the NVIDIA SMI command. Okay. NVIDIA SMI space dash I 7. So this is, I'm seeing the last GPU over here. Okay, so this will print out only one GPU for me. Okay, so the GPUs are numbered from 0 to 7. So I'm seeing the seventh GPU over here, and the seventh GPU, the MIG mode is disabled. This is how you list your GPU. Okay, now if I want to enable MIG mode inside this GPU, what will I do is I will type and sudo. Okay, so sudo is very important. So you need to have admin privileges inside this account. So sudo NVIDIA SMI. So to which GPU I want to enable MIG? I want to enable MIG in the last GPU, that is 7th. Then I will specify MIG is equal to MIG1. So what this will do is it will ask for the password, and I will type the password, and then it will start and it will enable MIG mode inside GPU number 7. Now if I again do this, NVIDIA SMI 7, okay, so I will be able to see a enabled flag over there. See, you can now see enabled flag over here, but it is saying no MIG devices found because we still haven't created any MIG instances. Okay, so over here there was no there is another tag over here of MIG devices, and there is a tag over here of GPU. Okay, and earlier there was only the tag of the GPU over here. There was no column of MIG devices. So we have enabled it in just one GPU right now. Okay, if we do the NVIDIA SMI for whole, that is all the GPUs inside your server. So over here you can see the MIG mode is enabled only on the 7th GPU. For rest all of this it is disabled. Okay, I hope that everyone was the admin people were able to understand this, that how to enable it. Okay, enabling it is very simple. You just need to specify the GPU number, and then you need to specify the flag for the MIG instance. Now, disabling it is also very easy. Instead of when you have enabled it, instead now it is 1. Now, if you want to disable it, you just specify 0. And when you press enter, the MIG instance should be disabled then. This takes a little bit of time, maybe 30 seconds maximum, but it creates the GPU instance. Okay, so now it is saying it has disabled. Now if I just check once again NVIDIA SMI dash i7, so over here we can see the 7 GPU, now it is disabled. So this is how you can enable and disable a MIG instance. Now this is the first part that you need to do before running any MIG instance, that is enabling the MIG instance, that is sudo NVIDIA SMI hyphen SMI it is. then dash I. Now I will do it for the sixth GPU, maybe Mig 1. Okay. Now the Mig mode is enabled inside the GPU. VTIA SMI dash I7. Okay, so it is showing that the Mig mode is enabled. Now let's see, after enabling Mig mode, what type of, what all profiles that we can create. So earlier I showed you there are actually 4 profiles, that is 5 GB, 10 GB, 20 GB and 20 GB. Okay, now let's see how we can list these different profiles. So listing these different profiles is very simple. You just need to call sudo nvidia smi dash lgip, that is list GPU instance profiles, lgip. Oh, sorry, we need to specify Mig also. Yeah, so now this is all the profiles that are available for GPU number 7. So if you would have enabled Mig instance on any other GPU also, that is let's say for GPU number 1 or GPU number 2 also simultaneously, so you would be able to get over here these profiles for GPU number 7 also, and then this GPU number 1 also may possible. Okay, now you can see that how many number of profiles there are available. There are actually 1 2 3 4 5 profiles available. The first profile is the most
Hello, one question, sir, please.
yes, yes sir.
Uh, as per the last command sudo nvidia smi mig space dash lgip, the
Yeah,
list group instance profile. So it is showing the only 7 number GPUs profile. If
yeah,
7 or 6 another GPUs are also enabled, then it will show both 7th and 6th number GPUs profile.
yes.
Okay, sir.
This table will be very big then. Over here
Okay.
there are only 5 profiles for 7 number. If I enable one more also right now, then
Yes,
another,
sir.
it another table, like 5 more things will be available inside this table. Only this 7 would be changed to the number of GPU that you have enabled, but over here right now I've enabled only for one GPU, so it is only
Okay.
showing for one GPU.
Okay. Okay. Thank you, sir.
Okay. All right. So now over here you can see the name of the profile, that is Mig. This is the first profile, 5GB profile, 10 GB profile, 20 GB profile, 20 GB profile, and then last is the 40 GB profile. And you can also see that how many instances are free and how many total instances there are. So right now in this 5 GB profile, you can create 7 instances, and there are total 7 instances. Over here, you can create 3 10 GB instances, and total is 3 10 GB instances. Similarly, for this 20 GB profile, you can get this two 20 GB instances, and similarly, you have total 2. So you have 2 free right now, that is, you can create 2, and the total is also 2. And right now, over here, you can also create a 20 GB profile for this also using this one, and this is also one available. And the only thing that you guys want to note over here is the GPU ID. So this ID we will be using for creating the profile. So if you want to create a 9 profile number, this profile number. Okay, sorry. So if you want to create profile number, this profile number 3, so you need to have this profile ID that you need to copy from here. If you want to create a GPU instance for this profile, so you need to copy this profile. If you want to create a GPU instance for this profile, you need to copy this ID. Now the basic difference, let me show you what all other things are available. So the other things that is available over here is, if you create a 5 GB profile, you will not exactly get 5 GBs. You will get around 4.75 GB of memory. Similarly, in the case of 10 GB, you will get 9.75. In the case of 20 GB, you will get 19.62. And in the case of 40 GB, you will get 39.5. So this is actually the overhead that is calculated, and only this much slicing is possible right now in this update. Maybe we, as the system matures, we can get even better utilizations over here. Okay, and with this 14 GB, you are getting 14 streaming multiprocessors. So each of this profile gets its allocated 14 SMs. So SMs are actually analogous to the number of cores. So you are getting 14 number of dedicated cores for this profile, this one profile. So over here you have 7 profiles. Okay, so 14 into 7 is the total number of that you can get. And over here, if you might be wondering that, okay, why we have 20 GB this and 20 GB this, 20 GB, 20 GB is the same. But the only difference, 20 GB, 20 GB over here has the number of SMs. So over here in this 20 GB, you have 42 number of SMs, but over here in this 20 GB, you have 56 number of SMs. So depending upon your use case, depending upon your compute capabilities that you are going to implement, maybe you want 56, you don't want much memory, but you want more cores available. Okay, so maybe your batch size would be very small. Maybe you are using a very small image size, so you want less number of less number of memory, but you want more number of SMs. So this is the difference. So how you can create a, now this is how you can list a profile, list GPU profiles. So this was the very easy command, that is NVIDIA -SMI MIG -LGIP. Okay, now let's create a profile. Okay, now, okay, so before I go with that, there is another simple way to see the LGI, this listing. So over here, if I do LGI double P, so I will be able to see it in a human readable format, which is very easier to understand also. So over here, GPU number 7 with profile ID 19 has these many availables right now. That is 0, 1, 2, 3, 4, 5, 6. That is 7 instances can be created for profile ID 19, which was 5 GB. Then profile ID 14, 3 instances can be created, which was 10 GB. Okay. And then similarly over here, this 20 GB, 2 instances can be created. And similarly over here, this 20 GB only one instance can be created, and this 20 GB, 40 GB only one instance can be created. So once you get to know all of this reading this also is very simple. That okay, now I want to create the profile ID 19, so I will copy this and I will start creating it. Okay, so I'll take a quick pause over here, 10 seconds pause. Feel free to ask any questions. I'll drink a sip of water by the time. Okay, so were there any questions? No? Any? Okay, so now let me show you how to create a profile. So up until now, I think that this was pretty straightforward. Listing profiles, enabling Mig mode, it is very straightforward to do. Okay. Now let's create certain profiles. Creating profiles is also very simple. So what we will do is we will create GPU instances. So how will we do that? Firstly, for creating any GPU instances, firstly what we need is we need the this uh, the profile ID. Okay, so we want this. This is the important one. Okay, now let's create one for the 19. Now NVIDIA SMI and sudo command is very important right now over here because you need to have admin privileges available to run any of these commands. So wherever I'm doing a sudo, that is important. But wherever I'm not doing a sudo, it can be run with the simple user also. Okay, now let's create a GPU instance. So we want to create this GPU instance. That is, I want to create a slice of 5 GB in my GPU. So how will I do that? NVIDIA SMI Mig dash create GPU instance CGI profile ID number 19, then dash C. So this will create a 19 instance. Okay, so it is saying that this has successfully created a GPU instance and it has also created a compute instance according to the GPU instance. So you have now you have a GPU instance and a compute instance available inside your GPU of 5 GB of this profile. Okay, so your now new instance has a profile of 5 GB and it has number of SMs of 14. Now let's see if it is having it or not. So now if I do NVIDIA SMI dash I 7, so now on the Mig devices I would be able to see it. Okay, so over here you can see in this Mig device I can see a Mig device available and 5 GBs is created. Okay, this is how easy it is to do inside a Mig instance creation. Now you have created a Mig instance. Now let's say you want to create multiple Mig instances. Now if I do another, firstly let me do another listing. So if I list it again, Mig list GPU instance profile. So over here I should be able to see 6 now. Now I've created one and only 6 are available. Now let's say I want to create 3 more. Okay. So what I would want to do is I can create multiple GPU instances at once also with the help of that single command only. How will I do that? After CGI, I will just pass this. Just a minute, guys. I think my system is giving me a little bit of a lag. Just a minute. So now we can see that there are only 6 instances available over here. Now if I want to create a GPU instance of 14, then let's say I want to, now I have used 5 GBs. Now still I have 35 GBs available. So still I can create two of these. Now let's see how we can create multiple GPU instances. So same, and sudo nvidia dash smi space mig space create GPU instances. Now we want to create 2 of 14. So how will we do that? 14 comma 14 dash capital C. So let's see. Sorry, spelling mistake, guys. NVIDIA semi. Okay. So it is saying now it has successfully created a GPU instance and a compute instance of 10 GB. Then it has again successfully created a GPU instance and a compute instance. So now I have successfully created 2 GPU MIG devices with the help of the single command over here. Okay. And how easy it is. You already saw that. Now let's list it out to see that, okay, if we are able to see that or not. I7. So now in the 7th part, we can see that there are two 10 GB instances created and one 5 GB instance created. Okay, this is the case. And this is how easy it is. Now let's see if we still have any GPU instances available. We have 10, 10, that is 20 GB, 25 GB. Okay, so 25 GB is used up now. Now let's see how many more we can create. Okay, so to create that, how we need to create it, we need to list it out. So listing list GPU instance profile. Okay, so over here you can see that you can either create one of this, or you can either create two of this, and you cannot create any of this now because it is not possible, because we have already used up half of the memory and now we cannot create a 20 GB one. Okay, now let's assume we want to create two more of this. Okay, then how will we do that? Simple command sudo nvidia -smi space mig space uh, okay, so one more thing that I wanted to specify over here was, over here I only have enabled one mig device, so I don't need to specify the number of GPU. All right, I was just doing sudo nvidia smi mig directly creating GPU instances. But maybe day after tomorrow you would have enabled in two devices, so you would have to specify the GPU number also over here. All right, so this is also an important thing to understand. So firstly, what we do is we specify to which GPU we want to use MIG. So we have specified -i7, then MIG CGI. We want to create two more of 19 instances. So 19 comma 19 space dash C, capital C. Okay, sorry. Just missed out a parameter, I would think. Just a minute.
I think you have typed wrongly CIG. CGI, it should be CGI.
Great, sir, great. Thank you.
Okay.
Thank you so much, sir. I7. Okay. So now, because I'm specifying the number of GPU also over here, this makes us specify the number of GPUs also available. Okay. Let me remove this. Maybe I am facing a problem over here. Yeah. Okay. So now if I list it out again, NVIDIA SMI -i7. Okay. So now we can see that we have created a lot of GPU instances. That is 5, 5. Then we created 5, 5, 5, then 10, 10. All right. Now you must be wondering that what is the 16, 16, 8, 8. So this is actually the amount of RAM that is allocated, I would say, is mapped to your GPU instance. So for a GPU instance, almost double the RAM is mapped. So over here in the system memory, that is RAM is the system memory over here. So for a 10 GB, almost 16 GB of system memory is mapped. So similar to that over here we are getting. So this is how you can create GPU instances. Okay. Now, if I list my GPU instances again, okay, I'll have to do a sudo NVIDIA SMI dash test GPU instance profile. Oh, sorry, I did not type Mig. So now all of the free are zero now because we have used up all the profiles available. Okay. Now this is how easy it is to create a Mig instance. Now, after creating a Mig instance, using up the Mig instance, let's first see how we can destroy a Mig instance also, because we need to destroy the Mig instance also if you want to create another instance. Maybe right now I'm having two 10 GBs over here. Okay, this is 10 GB, this is 10 GB. Now there is a request coming up maybe day after tomorrow that okay, I want 20 GB or something like that happens. So over here, then you what you have to do is either you have to destroy these two, or you'll have to destroy these two together to get a 20 GB out of it. So to get something like that, first what you want to do is you want to destroy the GPU instance. So destroying the GPU instance is also very easy. Firstly, you need to identify what GPU instance ID, GID you want to, what GI you want to destroy, and what CI you want to destroy. Okay, for the seventh. Okay, so you get your GID and your CID, CID and GID. Okay, so this is also important to understand. So you can see that you have different GIDs, but you are not. It has the same CID available. Now let's say I want to destroy these two. So how will I do that? So destroying also is very simple. You need to type sudo NVIDIA SMI space Mig GPU number. Okay, I need to assign to which GPU I am destroying. So in my case, I only have enabled Mig inside the seventh part. So over here, I'm destroying it inside it. So -7. Then I will first specify the destroy instance ID. So DCI. Okay. Now I want to destroy the compute instance. Now I want to destroy this instance. No, now which instance I want to destroy? I need to specify both. That is the CID. So I want to destroy the 0 CID. Okay. And then I want to specify the GID. So I want to destroy the this one 3. Okay. Then I will specify the GID 3. Now I press enter, so it will say that it has successfully destroyed compute instance ID 0 from GPU 7 and the GPU instance ID 0. Okay, now if I list it again, it is NVIDIA SMI dash I7. So now I can see only 110 GB available. The other 10 GB is destroyed. Okay. Now if I list my GPU profiles available also once again, so I would be able to see some things available now. Okay, now what was the command for listing? Sudo NVIDIA SMI Mig list GPU instance profile. Okay, let me just quickly find this out once again with the help of NVIDIA SMI dash. Okay, so NVIDIA SMI dash L also gives you the list. So over here in this list, you can see your whole server. So in this, you can see all the GPUs. And for the seventh GPU, you have your 4 GPU instances running. Okay. Now let's assume you want to destroy all of this. Okay, you want to destroy 10 GB this also, 5 GB this also. So how would you do that? Firstly, you need to see which CID and which GID these are of. Okay, so to see that, okay, now let's destroy this also and let's destroy this also. Okay, so destroying command is very simple: sudo nvidia -smi space mig space the GPU number that I want to destroy, that is using the I. Then what I want to do, I want to destroy compute instances. Okay, now I will specify the CID. So the CID is 0 and I will specify the GID. So the GID is 5 in our case over here. Okay, so it has destroyed compute instance ID 0. Okay, then I will destroy this one also. I will destroy this one also. Okay, 9. So this is 0. CID is 0 only, and this is 9. So I will destroy this also. Sudo nvidia smi for which device? 7th device. Destroy compute instances. CI0, GI1, GI9. So it will destroy compute instance ID 0 from GPU instance 7, GPU instance ID 9. Now let's list it once again to see what all we have available now. Okay, so we only have 2 available now. Okay, so this is how you can create a GPU instances and then you can destroy GPU instances. Now let me show you how you can use a GPU instance. Okay, using a GPU instance is also very simple. Let me first wait here to find out any more doubts that people are having. I hope that the people were able to understand the pretty straightforward commands that were there were. So the pipeline is very simple. Firstly, you need to enable Mig instance, then you need to list the Mig instances, then you need to create the Mig instances. Then once you're done, you need to destroy the Mig instances. Okay. And I'll share with you the document at the end of this session so that everyone can, so the users who have admin, the users who will have admin privileges should be able to understand this in a better way, because people don't need the simple user don't need to understand this. The only the user who will be allocating resources need to understand these commands very properly. Okay, so now let's move forward with help so that you guys can see how to use a GPU instance. Okay, now for the people over here, you would already remember the NVIDIA Docker run command. So over here, I'll show you the NVIDIA Docker run command. There's just a little bit of a modification inside the GPU NVIDIA Docker run command, which you need to do when you are using Mig instances. Right. Now let me show you that. Excuse me. Sorry guys, just a minute. It is taking a little bit of time for my screen to load up. Uh, yeah. So people might already be knowing these commands. So Docker images. Okay. So over here, this will list out all the images for me. All right. Now let's say I want to run this inside my GPU Mig instance. Okay. So let me show you first how many Mig instances I have available. So I have two Mig instances available. All right. This is the first instance. This is the second instance. Okay. Now, if I want to use this Mig instance inside any command that I want to use, now I want to use this Mig instance inside my Docker. Okay, so how will I do that? Firstly, I will type whole NVIDIA SMI, NVIDIA Docker run command. So NVIDIA Docker run IT RM. Then over here, I will specify the GPU number. Okay, NVIDIA visible devices is equal to. Now over here, earlier we just need to earlier what we need to do is we need to do 1 comma 2 comma 3 comma 4 depending upon what GPU we want to use. But right now we want to use the seventh GPU, and inside the seventh GPU we want to use the 0th instance. That is, this is the first instance. Okay, so we want to use the first instance. So this is how easy it is. How do you modify your NVIDIA SMI command for this GPU instance? So 7:0. All right. And now NVIDIA visible devices 7:0. And then over here, we will specify the Docker image that we want to use. So the Docker image that we want to use is this one. Okay. We will copy this and then we will specify the tag also. Okay. Any image you can use. It doesn't matter. I'm just showing you how to enable your Mig instance. Okay, this is the only thing that is changed right now inside a Docker run command when you guys are using your MIGs. Okay, now if I run this, okay, there is an issue. Sorry, I have provided 2 columns. This should be a dot. Okay, so it has started running successfully. Now I'm inside my workspace. Now inside my workspace, if I do NVIDIA SMI, I will only be able to see the 5 GBs. I suppose that should be the issue. That should be the case. So over here, we can see the whole GPU, but we can see the whole GPU, but we are only being assigned this 5 GB. Okay. So now you cannot see the memory of the GPU over here. The memory is 0 because we have enabled Mig. And the only memory that you are available inside this workspace is 5 GB. Now you can start running any of the Jupyter notebooks. Over here, you can pip install Jupyter and Jupyter Lab. Okay, and then you can start running your Jupyter instance over here, just like we did for the past 4 days. Okay, the only change that has happened over here right now is in the NVIDIA Docker run command. And this is the only change that will happen inside your command. So you need to specify the port number also using the -p. You need to specify the mount also using -p. Okay, and I've already shared with you guys those commands. The only difference that has come up over here is with the help of this. Okay, now if I want to use the first one, I can just specify 7:1, and the other user can use this one. And if I do NVIDIA SMI again over here, I will be able to see only the 5 GBs, nothing else. Okay, over here you cannot see the 40 GB available. Okay, you can only see the 5 GB available. All right. Now this is how you can run multiple commands. So even if I want to go inside this user, maybe I'm from the test user. Okay, over here now I am the test user. Earlier over there I was uh, the admin user. But right now in the test user also, let's see if we can use the MIG or not. So NVIDIA dash semi dash i7. So I can see the MIG instances created over here. Now let's say if I want to use this MIG instances. So how will I do that? Over here, firstly, I'll have to see that, okay, which MIG instance I've used over here. So the MIG instance that I've used over here is the 7:1. So I can use the 7:2 over there. Okay, so I've used the 7:0 over here, and I will use the 7:1 over here. Okay, 7:1 over here. All right. So over here,
One question,
now,
sir, please.
yes.
Hello. As this NVIDIA Docker command, you have assigned NVIDIA underscore visible underscore devices equal to 7:1. Means it will use only one instance.
No, it will use the first. So there are two instances available over here.
Okay,
this is
okay.
the instance, and this is the first instance. Okay, so
okay.
In this case, this is the last GPU, right? So if you remember 0, 1, 2, 3, 4, 5, 6, 7. So similarly,
Okay.
this is the 0th one. This is the first one.
Okay.
So this is how indexing is happening over here.
But sir, at the normal user level, how it will be decided? It means my question is that I do not assign. I only write equal to 7, not write :1.
Mm-hmm.
Then this will work or not?
No. If you have enabled MIG over here, you cannot just type in 7. You need to type in 7:something. You can,
Yes.
because over here we have enabled MIG instances in your 7th one.
Okay.
Okay,
No,
so
sir.
now
We should. According you, we should type 7:1. If I do not write 7:1 after creating the instance, then it will work or not?
it should not work. I have not tried
Not
that,
work.
but not work because it will not be able to find the 7th GPU. Because there is no 7th GPU right now. Let's try that out also.
And sir, on the machine DGX machine level, if various faculty members will use this machine for their purpose, then we have to create the separate account for them.
Yes, I think that should be the case. You guys can
Okay,
create non-user, non-admin accounts for the faculty members and decide GPU numbers for them, and then they can use that GPU numbers.
Okay, sir.
And over here, as you were saying that if I specify 7 over here, okay, if I have enabled a GPU instance, all right, I've enabled MIG on the 7th device. Now, if some person is not, if some person is not using the MIG device, that is 7:0 maybe, okay, he's
Yes,
not
sir.
using 7:0. He's just typing in 7 over here.
Yes,
So
sir.
that he will get over here after going inside the workspace, he will get this error.
Okay.
Because
Thank
it
you,
will
sir.
not be able to initialize the CUDA drivers. So if I do NVIDIA
Okay.
SMI, it will not be able to work. Okay, it will say that no MIG device is found, no GPU instance found.
Okay, sir.
And he will not be able to use the GPU. So if a MIG instance is enabled inside your GPU, you need to specify 7: the ID of the MIG. It is the
Okay.
first, it is 0 or 1 or things like that.
Clear, sir. Thank you.
Clear? Great. Now I am inside my container over here, and I'm using this Mig device. Okay, and over here I'm inside my another container where I'm using a different Mig device. And NVIDIA semi. Okay, so the GID of this device is 10, and this is the 5 GB one, and the GID of this device is 13, and this is the 5 GB one. So if you remember, I created two 5 GB accounts, one with one is having GID 0, and the another one is having GID 13. And now if I see this all together from here, NVIDIA SMI-i7. So the 10 GID1 is the 0th GPU, this is the 0th MIG device, and this is the first MIG device. So this is how you can create MIG devices inside your user, and then you can access those MIG devices inside your GPU, inside your containers. Okay, so over here, let's type in exit. So any non admin user can also use MIG devices, but any non-admin users cannot create MIG devices. Okay, so if I type in sudo, this is a non-admin user. Okay, test is a non-admin user. So if I type NVIDIA SMI MIG list GPU instance profile, so it will ask for the password of test, and then it will say test is not a sudo user. This incident will be reported. Okay, so this means that test is the test user, that is the user that I have created earlier, is not an admin user, so he will not be able to do MIG instantiation, deletion, creation, anything. But only the super admin can do that. Okay. Now, the last thing that I want to close with it, the last thing that I want to close with is I just want to show you how to disable the MIG device also. So I have created MIG devices over here, two MIG devices. So before disabling, you need to first destroy the MIG instances. So destroying command is very simple: sudo NVIDIA SMI MIG-i7, then destroy compute instances, compute instance ID 0. Let's see if we can destroy multiple ones. So 0, 0 and GPU ID 10, 13. 10, 13. Okay, so you can destroy it multiple GPU devices also. So I've destroyed all the MIG instances now. Now if I do NVIDIA SMI-i7, so now you can see the MIG devices enabled, but there is no MIG devices available. Now, the last thing that is how you can disable MIG instances. So I showed you earlier also how to disable MIG instances. NVIDIA SMI -i7 -MIG 0. This should disable the MIG instances. It takes a little bit of time, 20 seconds maybe, and it disables it. Okay, NVIDIA SMI-i7. All right, it is disabled. Okay. So that was all about MIG instances from my side, for specifically for the admin user. And I've also created a document for the user, so they can use this document. So I'll share this document with everyone, the admin user specifically. So I have showed you the steps also how to create a MIG. The first thing that you want to do is you want to enable MIG instances. Okay. After enabling, firstly, you want to list the MIG instance. Then you want to enable it, NVIDIA-SMI-i GPU ID, which GPU number you want to instantiate. Then you want to instantiate MIG is equal to 1. And then I've also Sorry, I will type a sudo also. Sudo is an important thing. Then the example is sudo NVIDIA SMI 0 mig1. So this will enable Mig instance in the 0th GPU, that is the first GPU. Okay. Now there is also a note over here that if you do not specify this, the Mig instance will be instantiated for all the GPUs. Okay. Then after enabling the Mig mode, the second command is to list the Mig profiles available. So listing the Mig profiles available is also very simple. I just demonstrated this to you as well. That is list GPU instance profile, or LGIPP also. This will list you all the profiles. So after listing all the profiles, you need to copy the profile ID that you want to create. Okay. Then you need to create the GPU instance using that profile ID. Okay. GPU profile ID. So how would you create a GPU profile ID? Very simple command, sudo NVIDIA SMI MIG create GPU instance. Then you will paste the GPU profile ID over here, which you copied from here. Okay. And then -C. This will create a GPU instance of that profile ID, maybe a 5 GB, 10 GB, 20 GB, 40 GB, depending upon your use case. And this is the example for it. Then the fourth thing is, if you want to create GPU instances, if you want to create multiple GPU instances, sorry, you want to list the GPU instances. So listing the Mig GPU instances, you can get like this also. Sorry, this is a repeated one. Okay, now let's see that how you can create multiple instances at once. So creating multiple instances is also very simple. What you need to do is just you need to pass the multiple instance GPU instance IDs that you want to create. You want to create a 19 GPU ID, you want to create a 14, and you want to create a 5 all together at once. You just pass them on towards once, and then you type in -C, and then all of them are created. Okay. Then at the last, after creation, I'll just also type in the list command. Sudo, not sudo, NVIDIA SMI -I. Okay. Over here also I'll type this command. And then the last thing, after you have done everything, you can just destroy the Mig instances. First, destroying the Mig instances, first what you want to do is you want to get the GPU number. Okay. So firstly, you list the Mig instances that are available using the GPU number, and then you run this command. Okay. That is sudo NVIDIA SMI MIG -I, the GPU number, then destroy compute instances, then the compute ID, and then the GID, that is the GPU ID. So example over here, I have shown you sudo NVIDIA SMI -I0, that is for this 0th GPU. I want to destroy the 0th compute instance, 0th compute instance of the third and the fourth one. Okay, this will actually be 0, 0. Okay, so this is how you can create and destroy a GPU instance. Okay, and the last thing is the slight change in the NVIDIA Docker run command, which is this. Okay, so this is the Docker command that you will be using. All right. So that was all for the session for today. I'll share with the necessary people this document also, so that they can try it out on their own and create it, try to destroy it, so that you can get a taste of it, how, and you get better at it. And the only thing that I would want to specify over here is not everyone needs to know these commands, because these commands will only be possible to run through the admin user. So the people who will have admin privileges need to understand this process and need to run these commands. Okay. But the earlier 4 days that we had, everyone needs to know all of these knowledge that we had for the 4 days. Now this 5th day is specifically designed for the admins and the people who will be managing the server. Okay, now the floor is open for questions, problems that you want to discuss, you want to clarify any more doubts that you have. I hope that I have told you everything about Mig and how to create, destroy everything.
Sir, just you have shows the word file, that's commands you have mentioned, to by whom you will share that file,
So,
to whom you will share. Yes, sir.
to whom should I share that? Who will be the admin who will be using that?
Yes, sir. How I will get that file?
I'll share it with.
तरीका तो है सर कि आप सैली मैम का मेल आईडीज है उनको भेज सकते हैं, या आप अपना मेल आईडी मुझे शेयर कर सकते हैं तो मैं आपको भी भेज सकता हूँ, अदरवाइज सैली मैम को तो हम देंगे ही देंगे।
ओके ओके, थैंक यू सर।
जी
शैली मैम से ले लेंगे सर हम।
जी जी
Okay,
मैं
sir.
शेयर कर दूँ।
Okay.
Oh. Any more theoretical doubts? This was a logistical doubt, maybe. Any theoretical problem? Any issue? I think you'll able to get into issues once you have ran it or at your end. Maybe once you what I'll do is right now is I'll share this with sir right now only, so that he can share it across to the necessary people. Maybe you can try it out on your own right now after lunch, maybe, and then we can have a session if possible. If you are facing any doubts, then we can have a session depending upon doubts.
Okay, sir.
Right, I'll immediately share with ma'am. Okay, as soon as I'm getting.
Okay, and one more thing that I wanted to show you, just a quick thing that I wanted to show you is how to create. People already know right now over here, right? The system admin would be knowing that how to create admin users and non-admin users, and how to restrict those admin users to their path. If the people don't know that, maybe I'll share those many commands with you guys also. You know,
Sure,
so
sir.
that yeah.
Yes, sir. If you share, that would be nice, sir.
Great, sir. I will share, sir. Not a problem.
Okay,
Sir.
sir.
So I will share the user, how to create non-admin users and how to create admin users. And creation of users
Okay,
can
sir.
only happen through admin user. Okay. So I will share that
Okay,
in
sir.
that document.